Hello everyone. Hope you guys are doing great. Today I'm going to talk about which Llama 3.1 LLM, and this has been released by the Meta, and this has too much potential. And many use cases I tried with the Llama 3.1, and also I checked it out the fine tuning where we needed the fine tuning. It's a pretty good result. I found it out, and also I'll show you the platform where you can go and you can play with Llama 405 billion parameter because it's a very big model and it's very hard to load inside of any kind of machine because it's a very costly process. But if you want to play with these things, I will show you the platform where you can go and you can play freely to check some of the use cases, right? So yeah, and the agenda, just I wanted to set up the agenda of this session. So I'll first play with the Llama 3.1 405 billion parameter and all the sort of thing. Also, I'll walk you through the key takeaway of the Llama 3.1, what they release on their own website, and we'll see the how we can use the Llama 3.1 programmatically. We'll do the fine tuning more to get the more precise result, and then we'll save the model and we'll do the further inferencing, future inferencing. Yeah. So yes, this is that. And now if you see, this is the official website of Llama 3.1. I will see their key takeaway. So you can see this is they launched three variants. One is 405 billion, 70 billion, and 8 billion. So you can use anything based on your system configuration. But we'll use the 8 billion for fine tuning for today, and I'll show you the 70 billion inferencing as well. So now, what are the key takeaways is there? Like they all completely open source model. That's the first thing that it's a data privacy. Like you are not going to send your data to any other third party platform. And number two is like it support context window is around 128K token. It's a very good, very rich token size, right? So if you will compare with the Chat GPT, they also support like similar. And next is if you will see, Llama is going to support agentic behavior, right? So this is pretty interesting for me. And if you will compare with the other open source LLM, they are not up to this mark. Like we can use that LLM directly as agentic behavior. Llama 3.1 release with the agentic behavior. I really wanted to play with this agentic behavior. So in future, I will try to create some content on the agentic behavior Llama 3.1. And if you will see that the ecosystem primarily reading go through the 25 partner and AWS, NVIDIA, and Databricks and Grok. Grok is very solid and powerful, which is also going to support Llama 3.1. I will also create some content with Llama 3.1 with Grok. And yeah, and also if you are from the US, you can see the try Llama 3.1 405 billion model in the US on the WhatsApp. So they support these things. Now, if you will see the evaluation, I will zoom in. So you can see MMLU task Llama 3.1 is beating GPT-4 and GPT-4o, not beating, but exactly same. Okay. And if you'll see the math task is around 73.8. And if you compare with the GPT-4, which is more powerful and 64.5, it's not on-prem as well. For this, we have to pay, but this is completely free, which is far better than the GPT-4. And if you'll compare with the GPT-4o, which is Omni, GPT-4 Omni version, and here the Llama is lagging, but it's okay because it's a free and it's a paid. So I'm thinking this is marginal okay, right? If you'll see different tasks, they evaluated, and the performance wise, wherever the dark it seems like it is better than the GPT-4. And if you will see the Llama's 8 billion model as well, so Llama 8 billion model, I'm just comparing with the GPT 3.5. And if you'll see all the tasks GPT 3.5 say, it is better than math task also, it is better than the other. I'll do the use cases as well. I'll try to show you some use cases. So what I will do, without wasting my time, I will go and I will do some of the mathematics question. So let me do one thing. I will directly, I tried it. So what I'm trying to do, I will just uh, give you one statistics problem. In case 60% of the student are male and 40% are female, and 70% are male a student, 80% of the female student pass in the test. If randomly selected student is passed, randomly selected student passed the test, what is the probability? of the student. I know this answer, and this is the question of the conditional probability and Bayes theorem. And based on this, let's see it identify the Bayes theorem, and the answer what is it? Yes, this answer is also correct. So yeah, I tried some mathematics problem, guys, statistics and the probability permutation combination problem. And you will see in my chat, I tried these things and it worked very well, decent. So that's the thing. Now I will directly jump into play with the code, like how you can do these things programmatically, right? So yes, so for that we have to install some of the libraries, and I'm not going to install now because I already installed. It will take unnecessary my time. So I am giving all the commands here. You can install it. Okay. So this is just okay. I'm using Unsloth, by the way. Unsloth is the again framework kind of thing like a TensorFlow transform, but it's pretty fast as compared to the if you will do the TensorFlow or PyTorch, it will be faster. So that's what I'm doing. And here I'm just loading my model, and this is the just a installation. Okay. So here I'm just loading this model, and you can see Unsloth Meta Llama 3.1 8 billion bits and byte 4-bit. And from where I downloaded, this is the model card from where I downloaded of the Hugging Face. I'll send this link as well. And yeah, and here I'm giving my max token 205. Choose any. We can auto support these things. I'm just loading this model. Yeah, let it to be load this model. And this notebook will be provided over my GitHub page. I will upload. I will attach the link as well. So from where you can do that. Now this model has been loaded. Now I'm going to do one thing. So whenever we are going to ask any kind of question, we have to format that question in some certain format, which is called alpaca format, alpaca format. And if you'll see the alpaca format, where we have a three thing called instruction, input, and response, right? So whenever we are going to give any instruction, there we are going to part wise the question, the three section called instruction, input, and response. The response will come from the LLM. So this is the helper function I created, which will convert your any question in form of the three section like instruction, input, and response in this alpaca format. That's all. So let me run this, and I'm going to give one simple prompt here. And this is the prompt, and I'm going to ask you a question based on this. This you can see this is the RAG, simple RAG. This is your document, and from where I'm asking the question, and I'm just converting these things in form of the alpaca format. So you can see just a simple alpaca format dot format, and here I'm going to pass my question instruction, and uh, this is my instruction, and this is my input. Okay, and you can see it converted these things in this format. This format below is the instruction that describe the task pair and all those sort of things. Yeah. And now what I will do, I will load my model for my inferencing faster language model. And you can see enable native 2x faster inferencing. This is just because of Onslaught. Okay. So now what I will do, I'm going to convert my input as a tokenizing my input. This is my instruction. This is my news. And just we are converting this is an alpaca format. That's all. And now I'm going to get my output, right? And if you, this is my output, right? And this you can see the output is the acquisition date of the January 5, 2022. This is pretty good. And if you'll see the result, yes, this is really nice. But this is not precise as well because I asked just a date and it added a something where the fine tuning will come into the picture. I will show you how we can get rid with this kind of problem with the fine tuning. Yeah. So you can see I asked who is the acquirer and it gave SCL is the acquirer, but I'm expecting it should be SCL technology, but it's giving some additional information as well, which is okay. That's fine. This is the code play without fine tuning. Now I will do one thing. I will create a new file, Llama 3.1 fine tuning. Okay. And .ipynb. And we'll see fine tuning result. Okay. So what I will do, I will directly load the model. This is my environment. Let it to be load. So it loaded the model. I'm just zooming it out so that everyone can see that result. Okay. So yes. So we loaded this model. Now what I'm trying to do, I'm giving some kind of, just I'm just giving something, data set I created. Again, this data set also I created through Llama 3.1. So you can give one example, and let me show you actually. The synthetic data creation task also you can perform through the Llama 3.1. So I will go to this platform and I'll give this instruction: create similar data, 10 similar data. I'll give the simple instruction, 10 similar data, and see it created the 10 similar data. Can you see this? Which company is the acquirer, and created very nice. And I'm using this only. I copied from there and I paste here. So I created like a sixth set of data, and I'm just doing the fine tuning so that whenever you will ask which company is the acquirer, so it will give exact result, ABC Corporation, something name. It will not give the additional information. So yes, this is the list of data set, and I have to convert this data into form of the data frame, right? So we'll do that. So here I'm loading the model. So if you will see, this is here I'm using the LoRa PEP, parameter efficient fine tuning. So this is the R value, target module, LoRa alpha, and the bias, and use gradient checkpoint pointing. And here I'm using unsloth. You can use true as well. This is fine. And yeah, so this is my model configuration. And again, I have to do one thing. I have to create my data set, right? So first of all, what we have to do, first of all, we have to design our alpaca format. This is our alpaca format, right? And next, what we have to do, we have to format. We have to format our any kind of question in this format, right? So this is the end of token, and tokenizer, whatever tokenizer you are using, it's a Llama 3.1. So that tokenizer, and it will add the end of statement token. And here I'm formatting my any kind of text in this format, in the above format. That's all. So that's the thing. And on top of it, let me do one thing. So we have to convert our list dataset. This is our list dataset in form of the dataset, right? So here I'm just doing that part. I'm importing my dataset and pandas library and data frame and list, this list, which is the dictionary, means list of dictionary basically. So that I'm converting in the data frame, and from data frame to data set I'm doing. And that data set, we are just mapping, formatting based on the alpaca format. That's all. And if you'll see, this is the seven thing is there in this. Three thing is there: instruction, input, output, and this text is based on the alpaca, because it's alpaca. Response will be in form of the text. That's what. Now, what we are trying to do, I'm just designing. Now we are going to create our trainer argument, right? Before that, I have to import this library, which is called supervised fine tuning trainer. It's coming from the TRL, and training arguments and unslot is bloat 16 supported. So let me create my trainer object now. And feel free, let me know at any point, do comments if you think. I already put my comments on, but if something is not justifiable and not able to understand some argument, do let me know. And in fact, I will do one thing: paste these things and ask with the Meta AI, explain all the arguments. Let's see what is happening. So yes, you can see trainer dataset is the dataset to be used for the training dataset text field, the name dataset text field, and tokenizer is used to process the text dataset data pre-processing, training argument. You can see training argument, gradient accumulation step, number of gradient accumulation step, which allows it for effectively large batch size, and FP16, BF16, whether to use the 16-bit floating point precision or BF16 precision for the training. It gave decent, guys. It's a like chat GPT. Even if you can try with the chat GPT, I think this one is better than the chat GPT, I believe. But you guys can try. So I'm using this. And yeah, okay. So now this is that. Now I have to start my training, right? So I design my training argument. Now I will start my training. And you can see I have given 60 steps, right? So the training will go till 60 steps. And you have to just notice this loss should get decreased. It should not increase with the time. Otherwise, overfitting will come, right? So let it to be uh, train the model while getting trained the model. I just wanted to say, like, if in this video, like, if you feel something is missing, anything which you want more discussion, feel free to put on the comments. I will try to address those things, and will try to separate video on it. And if something which I can explain or some code part is missing on the description which is not added, feel free, let me know. Anyways, I'm going to upload this complete code section on my GitHub, so that you guys can download from there, right? So yeah. Hmm. And you can see the loss is decreasing with the time, right? So this is good symbol. So now almost done. Okay, and it's pretty fast because we use the unslot. And first, number one thing is that our data set is also minimum, very less. So that's the first thing I can say. That's what training is quick, very fast. But if you'll use the richer data, biggest data as well, if you'll use the unslot, that's a benefit of using the unslot, right? So as already they are committing, it's 2x faster, right? And you can see I'm asking the same question what we tried here, and we got the result. You can see, right? SQL technology is the acquired, but this time I'm expecting it should give only SQL technologies because it's fine tuned, right? So now I'm converting my input to the alpaca format, and yeah, and the output we got, and this is the output here. Yes, this is the output, and you can see below is the instruction. There's a blah blah blah, right? The response and response request, and this, and you can see the response is something. We got the result January 5, 2022. Okay, we ask first one, right? What is the acquisition date? Okay, fine. But you want that particular result, right? So how we can get that result? Simple, very simple. I will now print the response here, and you can see we got the result. End of text is the last token, right? That's the thing. Now, similarly, can we check something instruction two, right? So we'll do the instruction two as well here only. And now we'll get the response, and you can see I'm getting just SQL technologies. Now, earlier we were getting, it's not precise result that I can say. Now fine tuning help here. So next I'm just trying to save my model. This is the challenging part, right? I spend my lot of time to save the model into save, and after saving the inferencing part took my time. So I'm just saving the model, and you can see currently there is no LoRa model is here, right? And if I'll save this, all the adapters, not complete model is getting saved, just adapters. Okay, so here all the adapters got saved, and the tokenization also got saved. Now we have to load this model, right? So to load this model, what we can do, I'm just loading the model, and I'm giving explicit this 1 minute. So I'm just loading this model here. This is my model, LoRa model I'm giving here. And yeah, the model has been loaded. Now what we can do, we'll give now the same input, similar input here. Uh, okay, and my instruction and this things. Okay, so this is the instruction, this is the date, and the loaded model. With the loaded model, I'm just expecting my response. Okay, this is the response, and if I'll calculate this response, I think we will get this response, right? Yeah. So yes, This that's all, guys. This is about the fine tuning and the loading the model and saving the model and reuse that model as well. So that's all for this video. And if you like this video, please feel free to subscribe the channel. If you are new on the channel, please do subscribe the channel and hit on a like button if something you like in this video, right? So thank you.